Hey guys, welcome back. Now in this lesson we will see a new demo with an object pose robot. In this lesson we will go through the steps that are necessary to perform pose estimation with a UR3 robotic arm in Unity3D. First of all, what is UR3? UR3 is this robot. So actually it is a new, smaller, collaborative tabletop robot for light assembly tasks and automated workbench scenarios. So it is about 11 kilos, it has a payload of 3 kilos, 360-degree rotation on all raised joints and infinite rotation on the end joint. The cost is about 20,000 euro, but it is a more advanced robotic arm, as you can see. There are also some even more advanced UR5, UR7, but I think UR3 is more than enough. So here you can see how much it can rotate and do things like image recognition that we will see together in this exercise. So what you will learn, you will gain experience integrating ROS with Unity. You will learn how to import URDF models, collecting labeled training data, training, and finally deploying a deep learning model. Now let's start with Unity3D right now. So first of all, you have to download the robotics object pose estimation, unzip this folder in order to import the necessary data to Unity3D and all the other stuff that we will see together. So first of all, let's start right now and open Unity3D. And now we will create a new project using the University render pipeline. So click here, new, and then we will use this universal render pipeline. So just create a new folder. I will name it pose estimation. And here, this is the folder that I will use. So select folder and then create a new project. It will need some time to load scripting assemblies, to load all the appropriate modules. And here we are. So you will see there are many things right there, but we will go to edit, project settings, and then here we have physics. We would like to go to solver type. So scroll down, solver type, and here this time we want temporal gauge shader. So click here and then go back to our project, where here is our project. Once your new project is created and is loaded, you will be presented with the Unity editor interface right here. So we will need to download and install several packages. From the top menu bar, we will go to Window, Package Manager. Here we are. And as the name suggests, you understand that the Package Manager is where you can download all the new packages. You can also update them, remove them. We will go right here and click to this plus sign at the top left corner and then choose add package from Git URL. So inside the zip file that you downloaded, you will see that there are 3 packages that we will have to download and import inside our Unity. So the first one is the perception package. We will copy this one, go right here and paste it and click add. So it says please wait, installing a Git package. This package, the perception package, will help us collect training data for our machine learning model. Actually, it is a Unity package that has to do with machine learning and how we can easily use it to collect and train our data and actually create our data model. The second one that we will use later is the URDF importer package. And this URDF is one package that we also used in our previous project. These packages help us to import a robot into our scene from a file in the unified robot description format. So if we click for more information URDF, so you will see that URDF is a package that contains a C++ parser for the unified robot description format, which is an XML format for representing a robot model. So we can use URDF to create a robot. This code API of the parser has been through our review brochure, etc., etc. What is really important is that here, this graph, where you can see that here is your robot application, but here is the URDF. URDF has to do with ROS packages, headers, and plugins that populates URDF data structures by parsing URDF files and other file formats, but the whole description of our robot, which means the description that has to do with the appearance of the robot, the dynamics of the robot, the plugins, and the ability to do specific things in our environment, all these data defines an XML file that describes the abilities and what each robot can do. So after installing the first one, go on and add the second one. This is the second address that we will use to import inside our Unity. Add package from Git URL. I will copy and paste the second URL so it actually goes on and installs the second Git package that has to do with URDF. And finally, the third package has to do with the TCP package manager, the TCP connector package. So it is a package that will enable a connection between ROS and Unity. So after installing the second package, we will go on with the third and the final one, copy and paste it in exactly the same way. So here we are. We have finally installed all the three packages. I will close the package manager, and here is my Unity editor. So in this left window is the hierarchy window. Here we have the scene. We have two tabs here, the scene and the game. The game is how we will see our simulation game when we will click to the play button. The third one is the inspector right here. We also have our project right here. You can see the fourth window. So we have several windows. The first one is the hierarchy. The second is the scene or the game, the main window right here. The third one here, we have the inspector. We have the properties of each object. The fourth one is our project right here. And finally, we have a second tab with the console with all the information or the error that we can see right here. Finally, we have some warnings, but there are only warnings. At this time, we will not give much attention in these warnings. Here also you will see there is the play button, how our game, our simulation environment will be seen from the camera always. Here we are. We also have the pause button and the step toolbar. If you don't have any of these windows, you can always go here to Window and then click to General, and you will see that you can always reopen one of these basic windows that we have seen together. So let's go on, and we will see that the perception package that we installed, it relies on a ground truth renderer feature to output labeled images as training data. So we will see together step by step how we can add this component to our rendering settings. So we will go to the project tab where it contains a search bar. Here we are, this is the project bar, and we will use this search bar to find the file named forward renderer. So right here, forward, and here it is, forward renderer.asset. We will click on the file to select it, and then you will see that in the inspector tab of the editor, you can click on the Add Renderer feature button and select Ground Truth Renderer feature from the drop-down menu. So click it, and then we will try to set up the scene. So as you already know, a scene is actually something that we build in Unity and contains any object that exists in the world, in this virtual world. This world can be a game, can be a simulation, environment. In this case, we have a data collection oriented simulation. So every new project contains a scene named sample scene, as you can see right here, which is automatically opened when the project is created. This scene comes with several objects and settings that we do not need. So let's create a new tab. Let's go to the project tab, click to assets right here, then to scenes, click create, go to scene, name this scene pose estimation, and double click on it to open it. So do you want to save the changes you made in the scene? Okay, we didn't make any changes, but yes. And here we are. Here we have a new scene, the pose estimation. So the hierarchy tab of the editor displays all the scenes that are currently loaded and all the objects that are currently present in each loaded scene. So here we have only our main camera and a directional light. So the new scene contains already a camera, the main camera, and a directional light. We will now modify the camera's field of view. We will modify the position. We will click to main camera, and here you will see the inspector tab of the main camera. Here are the main properties. We will change the main camera's position and the rotation. So click here 0, 1.5 this time, minus 1.4, and rotation X will be 20, 0, 0, 1, 1, 1. Okay, it is fine. Here is what our main camera is showing. And then we will click on directional light, and in the inspector tab, modify again the light's position to 0, 3, 0, and rotation to 40, 0, 0. Now we will add some more objects to our scene. So before doing so, we need to import some folders containing all the required assets. So inside the folder that you downloaded, you had of course packages to import.txt, but there is also a folder named required assets. Inside the folder required assets, there are materials, prefabs, ROS messages, scripts, etc. So we will drag and drop this folder right here to assets. Here we are. Now we have the folder required assets in the project tab editor. The first folder that we will use is the prefabs folder. So Unity's prefab system allows you to create, to configure and store a game object complete with all its components, all the property values, and all child game objects as a reusable Unity asset. So it is a convenient way to store complex objects. A prefab is a file that you can easily create an instance of the object in the scene from a prefab by dragging it into the hierarchy tab. So imagine, for example, that you have created a robot or car, for example, in a racing car game, that you have already created the model, the 3D model, programmed the way it should behave, it should accelerate and all these things. And you can create multiple instances of this object. So you can create a prefab, and then by dragging this prefab into your game, you can have multiple instances of this object. So for your convenience, there is specific prefabs that we will use in this simulation environment. It will be actually the cube, the goal, the table, the floor. So in the project tab, go to the assets, go to required assets, prefabs right here. And we will go to part 1 first of all. And then we will drag and drop the cube prefab here into the hierarchy tab. We will repeat this action with the goal, the table, and the floor prefab. Finally, we will add the robot and the URDF files in order to import the UR3 robot. So in the project tab again, go to assets, go to the folder required assets, then we will go to URDFs right here, and then UR3 with gripper. And here there is a file UR3 with gripper.urdf. So click right here and then select import robot from selected URDF file. So right click, import robot from selected URDF file, then click import URDF, and now we will go on with setting up the robot. So in the hierarchy tab, select UR3 with gripper game object, and in the inspector view right here, you can go to the controller script, as you can see, and set the stiffness from 0 to 10,000. Then the damping to 1000, and the force limit again to 1000. These are physics properties that control how the robot moves. So again, in the hierarchy tab, click on the arrow to the left of the UR3 with gripper. And here is the game object that you can expand, then expand world and select base link. In the articulation body, in this component, toggle on immovable right here. So this will fix the robot base to its current position. So now here we are. We have, as you can see, you can always click the left alt button and see your robot right here. I'll change it. Here we are. Here is the view. As you can see, we have our robot. So what we are going to do is actually train our robot to recognize where is in our table this object and place it above the appropriate image. So here is the table, here is the floor, here are the objects, and we will go on with pose estimation. So we learned how to create a Unity scene, how to use Package Manager to download and install Unity packages, how to move and rotate objects in the scene, how to instantiate game objects with prefabs, and how to import a robot from a URDF file.